Today, we're diving into a really cool method engineers use to stop problems before they even happen. It's called Failure Mode and Effect Analysis, or FMEA for short. And yeah, it's basically about predicting the future of failure so you can prevent it. Look, we've all been there, right? A project just completely goes off the rails, a brand new gadget breaks the first week you have it, a system crashes at the absolute worst moment. It always feels so random, so unavoidable. But what if it wasn't? What if you could actually see these failures coming and, do something about them? Well, it turns out they can. For decades, engineers in really high-stakes fields, we're talking aerospace, automotive, have been using a system designed to do exactly that. So here's what we're going to cover. First, we'll introduce what FMEA really is. Then, we'll walk through its modern 7-step process. We'll look at how teams figure out how bad a potential problem is, and then we'll tie it all together with a real-world example. Okay, so what is this FMEA thing, really? Honestly, the best way to think about it is like being a detective for failures that haven't even happened yet. At its heart, FMEA is a structured, team-based approach, and that word right there, proactive, that's the key. This isn't about figuring out what went wrong after the fact. It's about getting a whole team of people, engineers, designers, technicians, into a room to brainstorm every single thing that could go wrong, and then making a plan to stop it from happening in the first place. And FMEA basically comes in two main flavors. You've got design FMEA, which is all about looking for flaws in the product itself. The blueprints, the materials, the code. Then you have process FMEA. That one's focused on how the product is actually made, the assembly line, the tools, any human steps involved. So one is about the what, and the other is about the how. So how do you actually do this? How does a team put it into practice? Well, that brings us to the roadmap they follow, the 7-step process. This is the modern, standardized way to do it. You start with planning, obviously. Then you dive into the core analysis. First, you analyze the product's structure, then you figure out its functions, and then, the big one, you analyze all the potential ways it could fail. After that, you analyze the risk, you optimize the design to fix the problems, and finally, you document everything so you can learn from it. And this isn't just some arbitrary list somebody made up. This 7-step process is now a global standard. It was created by taking the best practices from North America's big automotive group and Germany's automotive industry and merging them into one single, harmonized approach. It's the best of both worlds. Now, the absolute heart of this whole analysis, the thing that makes it all click, is a concept called the failure chain. It's a really simple but incredibly powerful way to connect the dots from the root cause of a problem all the way to its final effect. The chain always starts with the end result, the failure effect. This is the so what of the failure. What's the consequence for the customer? Does it create a safety issue? What's the ultimate impact? The middle link in that chain is the failure mode. This is how the thing actually breaks. It's not the cause, and it's not the final consequence. It's the specific way it fails to do its job. Think of things like a seal weaks or a connection becomes intermittent. That's the mode. And finally, you trace it all the way back to the start of the chain, the failure cause. This is the root of the problem. This is the specific reason the failure mode happened at all. And this is the part the team can actually go in and fix. Okay, so let's say a team has identified dozens, maybe even hundreds of these potential failure chains. How in the world do they decide what to fix first? You can't do everything. Well, that brings us to our next section, quantifying the risk. It all starts with a simple 1 to 10 rating system. First up is severity. This is tied directly to that failure effect we just talked about. How bad are the consequences? A rating of 10 is the absolute worst-case scenario. We're talking about things that affect safety or break regulations. Next up, occurrence. This one's pretty straightforward. How likely is the failure cause to actually happen? A score of 1 means it's pretty much impossible, while a 10 means, yeah, based on what we're doing now, this is almost guaranteed to happen. And finally, there's detection. Now, this one is a little counterintuitive, so pay close attention. A high score is actually bad. A 10 in detection means you have almost no way of catching the problem before it gets to the customer. You're basically flying blind. A low score means your tests will catch it every time. In the old days, teams would just multiply these 3 numbers. But the new standard is way smarter. It uses this action priority table. And here's the brilliant part. Look at that top row. If the severity is high, a 9 or a 10, it doesn't matter what the other scores are. The action priority is automatically high, and the team is required to do something about it. This ensures the most dangerous potential failures always get top priority. All right, theory is one thing, but let's make this real. For our last section, let's watch FMEA in action with a simple example from the source material, a car window lifter. So in step 2, the structure analysis, the team just breaks the product down into its pieces. The big picture item is the window lifter. They decide to focus on one part inside it, the commutation system. And within that, they're looking at a lower level component, the brush card base body. Next, step 3, they define what everything is supposed to do. What's its function? Well, the commutation system's job is to transport electrical current, and the brush card's job to hold the brush system in exactly the right position. Simple, clear, and absolutely essential for what comes next. And now, step 4, they build that failure chain we talked about. They figure out a potential cause. The brush card body could bend. This would lead to the mode. It intermittently connects the wrong coils. And what's the ultimate effect for the driver? The window motor has a low torque and speed. In other words, the window doesn't go up and down right. See how it all connects? So, let's wrap this up. What's the big takeaway? FMEA is a proactive, team-based way to find risks before they ever become problems for your customers. It uses a structured 7-step process to guide the analysis and a smart risk system to focus on what matters most. In the end, it's a powerful tool that transforms the fear of failure into a clear opportunity to make things better. And that brings us to a final thought. FMEA is an engineering tool, for sure. But that core logic, thinking through effects, modes, and causes, that's universal. So if you could take this kind of systematic thinking and apply it to just one process in your own work or even your daily life, where would you start?